So you just spoke about, brought up a wonderful topic, tubes versus solid state, valves versus solid state. I did go through your product portfolio, and you do have some fabulous tube amps in your product line. I mean, is your design philosophy that you want to use tubes or against solid state, or do you also prefer solid state in certain again, for the matching, for their purposes, for their characteristics and stuff? And which would you prefer, tube or solid state? I mean,
so it's not. I never designed something in a dogmatic way. I would never say I'm gonna make a tube amp. The point is, that's the problem. How do I address this issue? Not I have this solution. Let's find a problem for it. So it's the other way around. If something, let's say a stage, a driver stage or an input stage, can sound better if it's a solid state design or a tube design. If a solid state is better, I'm going to use that one. So I don't have any predispositions or, let's say, prejudice about something. So far, I haven't found anything that resembles or matches a properly designed tube, because for every good tube, circuit, you can find 1,000 average and 1,000 bad ones. So it's not a matter of tube or nothing. It's a matter of what sounds best at this position, at this stage, and push the boundaries, see what's the limit, and use it. If we develop a solid state in the future which sounds better than tube, which is, I think, with the technology now, it's not going to happen. Then we can use it. So it's not a matter of having the solution and trying to find a problem to patch it up, but find the problem and address it, analyze it in all its stages, and say, how do I solve this issue? And this is not just in electronics. This goes in speaker design. This goes in in our analog solutions. You really have to think outside of the box. To address the issue at hand, analyze what's the issues and what the parameters is, and then try to figure out a solution. If that solution most of the times is tube related, that says something about tubes, not not something about what your philosophy, not, let's say, your prejudice is. Again, you have to see what's the best and use it.
But this is a very dividing thing in the audio community. There are people who are totally for tubes, and there are people who are totally against tubes. And there's a line which divides them, and they never cross over. A tube lover will always go with a tube amp. A solid state lover will always go with a solid state amp, and each will claim benefits, control, and dynamics, and solid state, openness, airiness, and tubes. I mean, that debate always continues. And I mean, I don't know which side of the line you walk on, but you said that you design it as per what the requirement is.
Yeah, the issue is what solid state you're comparing to which tube. So I think there's a big overlap. So some solid state will sound better than some tubes, but I find that the top performance, let's say the ceiling of performance is higher in tube technology. So it is a very big overlap. So a lot of tube amps will sound worse than many very good solid state, and the other way around. But I personally find that the higher you go in designs, there is a point that solid state just hits the ceiling, but the tube, continues. That is my take. Now,
Stavros, sorry, please go on. Hey, just finish your point, please. No, so we have Sandeep, who has a question to ask you. I think it's relevant to the topic in hand. So Sandeep, can I request you to unmute and yourself, and also maybe turn on your video just to ask a question?
Yeah. Yeah, Stavros, I guess you can see me now.
Yep.
Go on, Sandeep, please go on.
See, I have a question because what you have mentioned that you are driving an 845 tube with another 845 tube. So I understand the fact that why you would be doing it, but I mean, why in specific? I mean, what is the specific reason that you are using in such a large tube, driving a large tube? I understand if it's conventionally thought in a solid state, you're driving, if let's consider you're driving a bipolar. Okay, a large bipolar driven with a very large bipolar. So it would have a very nice current gain, and then you have better dynamics, better everything and all. Is it the same principle applying in even on the tubes what you are talking about?
We have developed with 813, not 845. So let's say to drive the 813, you need a very large voltage swing. So it's a better driving tubes is different than driving bipolars, which are current devices.
Correct.
So let's say you want very high voltage swing. An 813 will be much more comfortable giving that swing to the tube than having an overstressed smaller tube. The headroom is going to be, a magnitude much higher. Another thing is the slew rate is going to be higher because you're driving with higher current. And another thing, very interesting topic, when you're driving with the same type, not just another big tube, but if you're driving with the same type, you don't mix and match transfer curves. So you have a transfer curve driving an identical one. So the harmonic distribution, it's very different than driving two tubes in series. The harmonic distribution, if you compare them, they are very different. Usually they lack all the upper harmonics, so which is very detrimental to sound quality.
No, it's if you ask me, yeah, it's one of the best answers that you have given. I really like that. But I have a question on this, one of these FET triodes. I guess you do something with a FET triode. So is it like an input being a FET and then the next stage being a triode, or like is it a cascade kind of
no,
approach?
It's single stage. It is single stage, so it's not a tube that drives a MOSFET. So
the input is being a MOSFET, or is it? I mean, in the sense, is it like an input JFET or is it a cascade? I mean, that's what I would like to ask.
No, if you let's say if you see it in abstract terms, like a black box, it's going to have 3 terminals. Okay, so it's going to have a grid, a plate, and a cathode. Okay, if you measure this black box with a curve tracer, it's going to trace exactly like a triode. So it's going to be indistinguishable from the triode, which is using to copy its curves. The only difference is the scale of the current. So instead of having milliwatts, it's going to have milliamperes. It's going to have amperes. So that's only a distinguished mark. It is single stage. So one way to verify if a design is 2 stages or 1, if you have a tube driving a MOSFET, right? If you remove the tube, does it have power run through? No. If you remove the MOSFET,
it can't.
Yes. Does the tube drive the load? No. In a triode FET, if by magical intervention you remove the MOSFET from the circuit, the tube drives the load.
Okay.
So it still operates. And another way to look at it is when you have 2-stage cascading stage, each of the stage has different voltage at each time, different signal. Okay, in a single stage, if you probe, all positions will have the same signal. So that's the definition of a single stage. That's how you can verify if something is true single stage or not a cascade.
Yeah, correct. No, that's agreed. But I mean, why did you choose that way? I mean, mix matching FET with a tube and stuff like that. I mean, any
so the
specific thing?
triode has some very interesting characteristics. It doesn't have the usual hybrid behavior, which is mixing a transfer curve of the tube and then imposing it to the transfer curves of the MOSFET stage, either follower or not. The triode FET, because it has this characteristic, the transfer curves is identical to a tube and presents this characteristic. You can do some very nice things. You can design circuits that were not previously able to do that, because let's say you design a circuit, there is no active element that can fit into that circuit. If you want to use a single stage device that can amplify voltage and current at the same time with single stage, there is no active element to do that. Of course, there are some SPAD tube amps which can deliver 1 to 2 watts. That's a different story. But the triode FET has this characteristic that you can design some very, very simplistic circuits with it that were impossible to do otherwise. That's one of the key reasons why it sounds like it sounds. And another reason is that it allows the tube to really shine its characteristics over. Let's say you have a small, a small or medium tube, doesn't matter. So the sound characteristic of that tube is going to be very dictated by the, let's say, the output transformer or the driver of that tube or what is after it. With the triode FET, the way it operates, it allows, because it has much lower output impedance, it allows that tube to be, let's say, sound more tube than a tube. It will sound
capabilities. I know. Yeah. You're basically giving it steroid. Steroid that's steroid.
Exactly. So let's say you have this a very nice E280 tube, and you put an excellent output transformer to it, and you have, let's say, these distortion characteristics and this sound character to that stage. If you use that tube to the triode FET, you will hear more true to the tube sound than if it was going to be used in a true exactly. Why? Because it allows a tube to drive the parasitics of that output transformer in much better way, and can swing. So it is not affected in the same way from the load. That's why it will sound, let's say, more true to its transfer characteristics than using direct. So that's what I find very striking with the triode FET. When we compare it with a set amplifier, sometimes it takes the what you like about set amplifiers and takes it to next level. So it's not a matter of having a tube amp with more power or more drive, but it sounds more tube than a tube.
I got it. Yeah, it's very interesting one side.
Stavros. Continuing now on with our journey through this fascinating topic, could you talk a little bit about the Contendo 2? I believe this was a concept that originated way back in 2010 when you actually formed the company, and you've been working on it ever since then. And the Contendo 2, which has been born as of 2021, this is what you consider the pinnacle of audio reproduction?
Well, we started the company to make the Contendo, actually. So when back then, about 2009, when I had the first designs and first thoughts about what direction I wanted to go with the Contendo. So we started the company, and when we started developing electronics to develop that speaker, that's how our electronics line became into play. They were first developed to develop the Contendo. It went into a lot of iterations. That's why the huge delay from concept to launch it. We went from very thick composite horns to solid wood, which was a step back in 2012. I think it was let's say the changeover. We switched from infinite baffle bass to full bass horns back in, I think, 2015. So it was a long journey to do this. We switched from cone drivers to the mid bass to compression driver some years ago. So it was a long journey to get into the final, let's say, form of the speaker. Of course, we had a lot of, let's say, it was a fight between electronics and the speaker, because we developed the speakers to make the electronics to make the speaker. The speaker got better. Now the electronics had to catch up. So we further developed the electronics, but now the speaker had to catch up. So it was a ladder kind of thing. where it was internal competition between electronics and the speakers. Who is going to, let's say, who's going to be the bottleneck of performance into the lab? That's why it never, rested. The speaker, it was always developed and developed. We launched a few speakers before even launching the Contendo, which were not derived, but it's like
utilizing the technologies. Okay.
Exactly. For example, the horn-loaded tweeter, the horn-loaded ribbon tweeter was exactly. So it was stolen, let's say, by Symphonia, same as the diffraction-less 360 degrees Stratrix horns. They were, let's say, they were lended to the Symphonia. Although it took a lot of years to actually be presented, it gave a lot to the company in terms of lending technology to other speaker models. But mostly, in my opinion, it was a huge tool for our electronics lineup. It's an incredible magnifying lens of whatever is happening before it. So it was very important to have this speaker here as a let's say. Yes, it was the ultimate judge for our electronics. If it doesn't sound good in this speaker, we don't launch it. That's how it goes.
For those of you who don't know what I'm talking about, the Contendo 2 is a 4-way, completely passive horn system. It's an entirely horn-loaded system. It's got a separate set of lows, then the mid bass, then the mids, and then the HF, which are all horn-loaded, and they're all made out of wood. I mean, each and every single horn flare is made out of wood, and they're all Tractrix horns, like you said. They are not folded or in any way. So I think that's a feat in itself.
It carries some interesting technology. So that we try to address horn issues. One of them is, the horn vibrations, which is very, very important. It gives this, let's say, reverberation. Which is very, very audible, especially in the other offerings in the market. The honkiness is usually high order modes, which comes usually from bad geometry and over, using a horn over, let's say, not the correct bandwidth or overly wide bandwidth. And another very, very important let's say, artifact of the horns is the diffraction on the mouth, which is very, very audible. It creates this back emission, which gives you the honkiness on the horns. So this is what we try to eliminate it with this design, to cover all these three aspects.
Sorry, my battery was dying, so I'm telling my son to get the charger for the thing. But there's a question here in this design of yours. You've gone 4-way, but you've gone completely passive. Was that an active choice? I mean, or don't you think going active with separate amplification stages for each of the 4 ways would have been a lot efficient, power efficient, as well as controllable? I mean, as far as control, power delivery.
With active, it makes sense not to divide, let's say, tweeter from mid-range. Doesn't make sense. What makes sense usually is the bass. Bass is what is really, really, let's say, can take advantage. The issue with active is that in many designs, it's mandatory because, let's say, you use a short bass horn, which is usually the case. They use much shorter bass horns to get the proper bandwidth. So they need equalization. Equalization means active. There is no way around it. So active in many horn systems is let's say, a prerequisite. Is a mandatory step to be operational. You can't operate without it. Contendo is passive because it can't play passive. It doesn't need equalization. The bass horns are very, very linear. They are the same, let's say, they're the same sensitivity, also very, very important. And also another factor why they usually go active to match the sensitivities. Here you have the same sensitivity, you don't need equalization, so you go passive. If you get, let's say, the same quality amplifier times 2 and go active, is it going to sound better? Of course. The issue at hand is, do you go active and use, run-of-the-mill amplifiers just to keep the cost at the manageable levels, or it's going to sound better? In my opinion, if you have top-notch amplifiers for the main, no, it's never going to be coherent. You're always going to hear the character of the second amplifier. So if you don't need active, let's say, operation, because again, you don't need equalization or sensitivity matching. If you don't have the same quality for all the amplifiers, don't do it. If you can afford to have the same quality of amplifiers throughout the ways, for the main, the bass, go for it. It's going to be audible better. At the show in Munich, we did a trick there, because what happened is that, to extend what I was saying, we used a single amplifier at the first day, but the problem was, it's sensitivity, no equalization needed. The problem was that because we set the speaker at the corner and the room was massive, it was like 270 square meters room, it got a boost, bass boost.
Okay, a bass boost, yeah.
But,
Wall loading,
yeah,
corner loading.
Exactly, because of the position. So it will either go, put the horns to the, another thing that we push the horns a bit back, more to the back, which was not correct. We had to put them more forward. The problem is, was going to be closer to the first seats, which was a bad move. If you ask me, less seats and proper position next year. If we had it, we will do it. But, we learn every day. We should have done that. But the problem was we had a big bass boost. So what we do is, even though we have an active filter built in or as an option in the crossover, so we could just plug another amplifier and use the active filter to it.
Subwoofer.
So yeah, the crossover has built-in active filter, so you can just plug another amplifier and use it in passive mode with just a speaker cable and RCA. You don't need to modify anything. But what we did is we used two amplifiers, bi-amping them, but I altered the response of the other one amplifier with its settings. So it was going a cross between bi-amping and an active stage. And we did this on the fly at the second day of the show, with what we had, even though we could go active. I found that bypassing even that filters, even the active filters with the trick we did was even better. So again, there are a number of ways to see things. Some claim that, okay, active even with moderate amplifiers, it's going to sound better. In some speakers, yes. For our speakers, let's say you have a top, let's say if you have one of our top amplifiers, passive versus active with much lesser, let's say, quality amplifiers, passive all the way, the difference is very, very horrible. So if it's not, let's say, mandatory, you go with what your budget allows in terms of amplifiers. If you can afford getting top-notch amplifiers, then go active. It's going to be beneficial.